something went terribly wrong. In the darkness of night, as the engines of a massive Starship upper stage prepared for ignition, a violent explosion shattered the calm. What should have been a routine static fire test turned into a catastrophe that lit up the Texas sky and sent shockwaves through the entire Starbase facility. No engine had even fired yet. But the upper stage was gone, obliterated in a blinding inferno that engulfed the launch stand and shredded nearby infrastructure. In seconds, a full-scale vehicle was lost. Twisted metal rained down. Debris flew across the test site and even across the Rio Grande. The destruction wasn't just unexpected, it was total. This was Ship 36, the latest Starship upper stage slated for integration with a Super Heavy booster for the long-awaited Flight 10. SpaceX had been inching closer to another test flight, possibly by the end of the month. That timeline was now a smoldering wreck. All eyes turned to the pad, to the aftermath, and to the questions. What went wrong? What caused such a catastrophic anomaly before even a spark lit inside the engine bell? In typical Elon Musk fashion, the answer came quickly, but cautiously. It might have been a COPV, he said, a composite overwrapped pressure vessel, small in size but crucial in function, used for storing pressurized gases like helium or nitrogen. These tanks, no bigger than a human torso, had a history. They've failed before. And when they go hard. When dawn broke over Boca Chica, the scale of the damage came into sharper focus. The test stand was still standing, but it looked like a skeleton scorched by war. Debris coated the entire area. The once functional scaffolding and stairs leading to the pad were gone. Gone not as in damaged, but vaporized. Steel beams bent like straws. Blackened panels hung loose. Where once there were propellant connections and plumbing intricately threaded into the heart of the structure, now there was only ash and ruin. Comparisons with earlier photos taken just days before painted a painful picture. Access platforms, prop lines, sensors, everything closest to the vehicle, had taken the full brunt of the blast and were now either warped beyond repair or missing entirely. Videos posted online by local observers revealed more than just scorched metal. They showed a site smoldering like a battlefield. One clip from Raptor Roost, Texas panned across the launch mount where Ship 36 had once stood. The four-legged stand still held its posture, defiant in the chaos, but its skin was melted. Every visible edge bore the blackened signature of a fire far more intense than anyone had anticipated. On the riverside edge, the structure that once allowed engineers to connect fuel and data lines to the vehicle had been annihilated. Not torn apart. Not simply damaged. Gone. Looking beyond the stand itself, the fire had spread. Smoke curled into the morning air, not just from the pad, but from the landscape beyond. Near the riverbank, grass and brush had burned away entirely. Vegetation that had grown for years along the Texas side of the Rio Grande was reduced to charcoal. And then came the truly surreal moment, when the camera tilted to the opposite riverbank. Debris. A large fragment of the vehicle had landed across the water, in Mexico. What was once a unified test platform was now scattered across two nations. One small explosion, if you could call it that, had flung SpaceX hardware into international territory. The destruction didn't stop at the river. Cameras picked up melted tanks near the pad. These included components of the deluge system, designed to spray huge amounts of water during engine ignition to suppress sound and heat. Ironically, even this system, meant to tame fire, had been partially claimed by it. Tanks still stood, but their silver sheen had turned to soot. Paint blistered. Hoses torn. Whether these tanks, some filled with propellant, others with water, were still safe was uncertain. Even if the metal held, the internals may have suffered irreversible damage. Replacing them wouldn't just be a logistical task, it would be a financial and schedule setback. The fireball that consumed Ship 36 was no minor mishap. It had stripped the hill beyond the pad of its greenery. Charred earth fanned out like an impact crater. From overhead, the site looked less like a launch facility and more like a disaster zone. Trees blackened. Soil cracked. Hours later, smoke still curled lazily into the humid morning air. Ash coated the walkways. Sensors blinked uselessly in the sunlight. But for SpaceX, this wasn't just a physical setback. It was an engineering autopsy. What had caused such an explosive failure without ignition? What part of the system had been compromised so violently that the entire vehicle and test structure were lost in seconds? Cops were the leading suspect. These pressurized vessels have always posed a risk in rocketry. They're essential for maintaining pressure inside fuel tanks and pushing fluids where they need to go. But when one fails, when the carbon wrapping tears or the inner metal liner ruptures, the energy released is immense. It's like setting off a bomb inside the plumbing of a spaceship. Elon's comment about a possible COPV failure wasn't just speculative. It echoed concerns going back decades in aerospace. NASA had lost missions due to COPV issues. SpaceX had seen anomalies with them before, including during the infamous Falcon 9 pad explosion in 2016. They were small, silent, and deadly. And on a vehicle the size of Starship, where many such vessels are tucked within thin walls and cryogenic tanks, even one failure can bring everything down. And so the countdown for Flight 10 is now in limbo. Instead of integrating a new Starship with Booster 12, SpaceX engineers are back in the grind of forensic analysis. Cameras, data logs, sensor readings, burn patterns. Every bolt that survived will be photographed, every wire scanned. They'll rebuild the test stand, yes, but first they'll rebuild their understanding of what went wrong. What's most striking in all of this isn't just the explosion, it's the pattern. Starship, for all its grandeur, is still in early development. And like all rocket programs, failure is not only expected, it's necessary. Iteration through catastrophe is how SpaceX has always moved forward. From Falcon 1's failures in the mid-2000s to Starship's belly flop tests that turned prototypes into fireworks, it's part of their DNA. This event, as destructive as it was, fits the mold. But this one stings a little deeper. This wasn't a flight. It wasn't a test of wild aerodynamic maneuvers or belly flops over the Gulf. This was a ground test. Static. Controlled. At least in theory. And that it failed so explosively adds weight to the challenges SpaceX still faces as they attempt to make Starship not just the largest rocket ever built, but a reliable one. As the cleanup begins, SpaceX must now decide how to proceed. Repairing the test stand is a given. But do they delay Flight 10 indefinitely, or swap in another ship and another pad while analysis continues? Do they redesign the COPV architecture across all vehicles? Do they revisit the plumbing layout, or reinforce areas previously considered safe? There's another wrinkle too, the FAA. Every anomaly at Starbase gets reported, cataloged, and reviewed. Depending on the cause, the agency could delay permits, requiring safety upgrades or deeper inspections. SpaceX will be eager to demonstrate not only that they understand the root of this failure, but that it won't happen again. Public trust, regulatory cooperation, and mission timelines all hang in the balance. But if there's one thing SpaceX has proven, it's resilience. They'll rebuild the stand. They'll swap out the tanks. They'll trace the fire back to its source. And they'll light the engines again. Maybe not tomorrow. Maybe not even next month. But soon. Because Starship isn't just a rocket. It's a revolution waiting to happen. And revolutions, as history teaches us, are never clean. Just a few months ago, this very launch site was scorched, battered, and cratered by a Super Heavy booster's raw fury, sending concrete blocks flying like artillery shells. But in typical SpaceX fashion, that disaster didn't mean defeat. The company responded not just with repairs but with improvements. The pad was brought back to life stronger, more resilient. And now, in the charred wake of yet another fiery setback, that same spirit is about to be tested again. The cleanup is already underway. Engineers in flame-retardant gear and safety harnesses are crawling across the wreckage, assessing twisted pipes and scorched steel. Work crews are sorting debris, cataloging damage, and tracing fire patterns to understand exactly what burned, what failed, and what must now be rebuilt from the ground up. The test stand, once a towering scaffold of precision-engineered hardware, will become the centerpiece of SpaceX's next wave of recovery. Feed lines that once funneled cryogenic propellants into the belly of Starship must be replaced. Electrical wiring fused by the heat must be rerouted or rebuilt entirely. Damaged tanks will either be refurbished or scrapped. And buried within all of that will be an intensive inspection of the water deluge system, which was supposed to tame the inferno, but couldn't. SpaceX will dissect the cooling network, the core pad interfaces, and the plumbing that fed superchilled fuel into the vehicle's complex tanks. Every bolt and valve will be scrutinized, every sensor retested or replaced. The entire test rig will become a case study in failure recovery. Fortunately, SpaceX isn't confined to one launch pad. At Starbase, redundancy is part of the design. Other static fire test areas exist, and flight integration towers are standing by. But despite this, it's not an ideal situation. The test site was a critical node in the preparation chain for Flight 10, which had been targeted for as soon as June 29, with a backup window on the 30th. Just days ago, teams were working around the clock to make that date. Raptor engines were being installed. Final pressurization tests were scheduled. Starship was nearing its moment. But the explosion changed everything. In seconds the schedule was shattered. Now, instead of preparing for launch, SpaceX is bracing for weeks, if not months, of recovery. The next Starship must be pulled from the assembly line and prepped from scratch. And even then it will need to be tested at a safe facility, integrated with its booster and re-evaluated under the ever-watchful eye of the FAA. A process that once felt like momentum has become, once again, a lesson in endurance. In the hours following the incident, SpaceX released an official statement. On Wednesday, June 18, at approximately 11 p.m. Central Time, the Starship preparing for the 10th flight test experienced a major anomaly while on the test stand at Starbase. A safety-clear area around the site was maintained throughout the operation and all personnel are safe and accounted for. Our Starbase team is actively working to secure the test site and the immediate surrounding area in conjunction with local officials. There are no hazards to residents in the surrounding communities, and we ask that individuals do not attempt to approach the area while securing operations continue. The language was calm, clinical, and reassuring. But beneath the formality there was urgency. This wasn't just a hiccup. It was a catastrophic loss. Later, Elon Musk followed up on X with a technical update. Preliminary data, he said, pointed to a nitrogen COPV, a small high-pressure vessel, located in the payload bay as the likely culprit. According to him, the tank failed before reaching its proof pressure, a detail that shocked even veteran engineers. If true, it would mark the first known failure of this particular COPV design. These vessels, while compact, are critical. They're made from an aluminum or titanium liner, overwrapped with carbon composite fibers. They hold pressurized gases needed for various control systems aboard the rocket. When one ruptures, it doesn't leak, it explodes. A failed COPV near the top of the vehicle would have introduced an abrupt and violent disruption to the vehicle's internal pressure balance. Such a rupture can tear through walls, compromise structural bulkheads, and worst of all, set off a chain reaction that leads to propellant mixing. When supercooled methane and oxygen combine uncontrollably inside a metal cylinder, the result isn't just an explosion, it's total obliteration. This isn't the first time the Starship program has had to learn painful lessons in fire. On Flight 8, another Starship V2 prototype met its end roughly 5.5 minutes into ascent. Telemetry revealed a flash near the aft section, close to one of the center sea-level Raptor engines. Moments later, an energetic event caused that engine to fail. The remaining Raptors attempted to compensate but began shutting down. Within minutes, vehicle control was lost entirely. By the 9:30 mark, all engines were off. The rocket, lifeless and tumbling, fell into silence. Flight 9 fared better but still ended in disappointment. The vehicle climbed higher, traveling for 46 minutes through various maneuvers. But an attitude control error compromised its ability to orient properly for re-entry. The vehicle never reached its planned re-entry posture. It skipped its Raptor relight, vented its remaining pressure in an automated abort and lost contact. No explosion. No fireball. Just failure slowly and quietly. Now, with Flight 10 derailed before it ever reached the launch pad, the Starship V2 fleet faces a reckoning. Only a few of these prototypes remain. After that, SpaceX will transition to the Starship V3, a redesigned version of the vehicle with significant upgrades. The new variant promises improvements in structural integrity, thermal protection, avionics, and Raptor engine design. SpaceX believes V3 will be the foundation for consistent, reliable flight. But first, they must close the chapter on V2, with all its setbacks, trials, and valuable lessons learned through hardware lost. In a statement that speaks volumes about their philosophy, the company declared, "Starship is designed to fundamentally change and enhance humanity's ability to reach space. This step change in capability won't happen overnight, and progress towards this goal won't always come in leaps. But by putting hardware into a real-world environment as frequently as possible, while still maximizing controls for public safety, progress can be made to achieve the goal of flying a reliable, fully and rapidly reusable rocket." That's the SpaceX way. Move fast. Break things. Learn. Repeat. It's not traditional. It's not risk-averse. But it's undeniably effective. SpaceX has achieved in 20 years what many aerospace firms haven't in 60. But the cost is sometimes paid in metal and fire. In melted tanks and shattered engines. In scorched steel towers and debris scattered across 2 countries. Soon there will be a press conference. Engineers will unveil findings from their post-incident investigation. Diagrams will trace the root cause from milliseconds before the blast. Spectrograms will chart the pressure spike. They'll release close-up photos of ruptured tanks, heat maps of the fireball, and perhaps even audio from sensors that captured the vehicle's final seconds. But all of that will come after the silence. After the smoke clears. After the hill beyond the test stand, blackened and still, reminds everyone just how volatile rocketry remains, even in the hands of experts. What comes next is predictable. SpaceX will rebuild. Crews will weld new structures. Pipes will be rethreaded. The deluge system will be upgraded. COPs will be redesigned or moved. The new ship, maybe ship 37 or 38, will be rolled out and prepared. Raptor engines will roar to life again. The countdown will resume. And the world will once more watch the black and white tower of Starship rise toward the stratosphere. But for now, this is a moment of pause. A reminder that even giants can fall. That progress demands resilience. That the road to Mars, the dream that drives every test, every launch, every late-night engine burn, is paved with failure as much as fire. And somewhere in the noise, behind the headlines and explosions, is a lesson in ambition. In not giving up. In building something bigger than ourselves. The test site will recover. The vehicle will be replaced. The launch date will shift. But the mission, the dream of a fully reusable rocket, of interplanetary transport, of building a future beyond Earth, that mission remains. It's just waiting for the next countdown.